This video is explaining graphing radical functions. I'm specifically going to be graphing cube root functions, so cubic root. We can still graph these in our calculator, but the difference between a cube root and a square root is that a cube root will actually keep going forever in both directions. So our key point is not actually our starting point, it's actually kind of the middle of our graph, which is one of the reasons why it's very important that we know how to find that key point. So our key point here is, again, we change our h, that becomes a positive 2, and we keep our k, which was a 0. So that key point is actually going to be in the middle of our table. So if we go to our y equals and we graph them, go to y equals, we actually go to math, and we go to the cube root function, so 4, and we type in the x minus 2. Now the minus 2 is inside the radical, so make sure that you see that in there. We'll make sure we press zoom 6 and we'll look at the graph. You see how it's going this way and then it's kind of curving, it keeps going? That 2, 0 looks like it's to be in the middle of our graph, which is what we want. So when we get our table of coordinates, if we go to this table, we want to put 2, 0, this 2, 0 in the middle of our screen, or we at least want to get 2, 0 in the middle, and we want to have 2 coordinates above it and then 2 coordinates below it. So we do want to try and put 2, 0 in the middle of our table. And so above it, we have 1, negative 1. So I want to put that above it right here. 1, negative 1. Then I'm going to keep going and find another one. It's that negative 6, negative 2. So I can do negative 6, negative 2. But then I want to go and do 2 more coordinates underneath the 2, 0. So the next one is 3, 1. And then if I keep going, find another one, I get 10, 2. Now obviously I can't graph this 10, 2 on this one, but I can graph the other ones. And I do want to make sure that it kind of at least resembles the shape from the graph. I do at least want to make it look like that. It's like a weird shape S. So I have negative 6, negative 2. And I have 1, negative 1, 2, 0, 3, 1, and I'll have 10, 2, which is way over here. Now the thing is that if you look at the shape of the graph, it's not just it doesn't have an angle. It's not like a Z or a weird shape with angles. It actually is curving. So you do want to make a S shape right in there. So be very careful on when you connect these three. So it does keep going. So it curves. And then it curves back to go this way. And does have arrows. So just make sure that these are curving. It's not like super curving and it's not angles. So it's not jagged. So the domain goes off of which way are your arrows pointing. Your arrow's pointing to the left and your arrow's pointing to the right. Well, that's both infinities. So the domain is from negative infinity to positive infinity with open brackets. Your range, same thing. So is your arrow pointing down and is your arrow pointing up? So yes, they're going down forever and up forever. That means also negative infinity to infinity. A cube root should be negative infinity, infinity for both domain and range because they will keep going forever. Now, I still want to talk about the transformations. Transformations. And we still want to talk about our a value. A is equal to a positive and a is equal to a 1. Our h value is equal to a positive 2 and our k is 0. So that doesn't affect anything. The k 0 doesn't affect anything. See how it went 2, 0, so it went to the right 2. That's where it should start at 0, 0, but it went right 2. So since it's positive, it's not reflecting. Since it's 1, it's not stretching or compressing. So this is a normal shape. So there is no reflect, no stretch or compress. It is going right 2, but it's not going up or down. If we want to talk about the function notation, even though it's a cube root, you still do the function notation the same way. It's still f of x, and then the minus 2 is inside with the x, so it's still minus 2. What this is doing is still just telling you that it's going right 2. That is what function notation does. It tells you your transformations without having to look at the parent function. This next example is written slightly different. So when you find your key point, you have to understand which aspect is what. Your h is still always a number inside with your x. Your a is what's multiplied to the function, so that's your 1/2. It's technically your negative 1/2. And your k value is what's attached by addition or subtraction. This negative 1/2 is multiplied, so that's your a. What's added and subtracted is actually that 1. So if I write out our actual transformations real quick, so a equals, this part is your a. That negative is attached to that multiplication. Then a is also equal to a 1/2 because it's multiplied to that cube root. Your h is equal to, again, you change your h, that becomes a -3. So the only thing left is that positive 1. That positive 1 is technically added to the other side. You could write that as +1 out here. So our k is technically equal to a 1. So when you see this, be careful about knowing what number that actually represents. So our key point in this one is actually at -3, 1. And when we graph this, we can actually check to see if that's true. So if we go to our y equals, clear it out, we have 1 minus, and since I have a new calculator, I can do alpha y equals, do 1/2. Then I can do math 4 cube root of x plus 3. X plus 3. I can still do that in the older calculators. I just have to put parentheses around my 1/2. Just be careful of that. So if I press graph, I think my key point should be at -3, 1. And if you look, -3 up 1 looks like it might be right there. So if I go to my table, see the different way the graph's going. -3, 1 is a coordinate. And we want to have that kind of in the middle of our graph. So because I have fractions, if I go back to here, if I just type in, instead of 1/2, I can actually put 1, so 1 divided by 2. And if I look at my table, I get the decimals. So if I did the alpha y equals, it gives me fractions in my y's as well. So if you don't want the fractions, you can actually put it with the parentheses instead. That's how you would put it into your old calculator as well. So that -3, 1 is the coordinate that we want in the middle of our table. -3, 1. And then right above it, we want that -4 and 1.5. See if there's any other ones that we can do. That's -11, 2. Probably won't be able to graph that one, but that's okay. So go back down to -3, 1, and then we have -2.5. So -2 and then 0.5. And let's go find another one. We have 5, 0, which we can graph, so that's good. So we have some halves which are okay to still graph because we can find those. So I can't graph -11, 2, that's okay. -4 and then 1.5. -4, 1.5. -3, +1. -2.5. And then 5, 0. So I don't have that other coordinate over here, but I know it's going to be way over here. If I look back at my graph, I know my shape is going to look very similar to this. There's my 3 coordinates together. So those ones I have to curve, but I have to curve it down this time. So I'm actually going to start at these 3. I'm going to curve down and go forever. And then it's going to curve up and go sideways. Go to the left. Right, so the domain should, again, left and right, it's going left and right, should be -infinity to +infinity. And then the range is also going up forever and down forever, so it's -infinity to +infinity. And we've already written out our A, H, and K so that we could understand where our key point was. So So if we're dealing with our transformations, this graph is going in a different direction than this one did up here. This one went up and to the right. This one went down and to the right because that was that negative. It's reflecting over the x-axis. So there's a reflect over the x-axis. It's also going, these were spaced out by 1s. These are spaced out by 1/2. So it's actually compressing. It's going slower. That's where that 1/2 came from. This is a vertical compress of 1/2. And if you notice, because these were spaced out by 1 going up by 1, these are spaced out by only 1/2. They're 1/2 the vertical height now. And then you can see that from 0, 0, it actually, this middle coordinate went to the left 3 and then up 1. That's where the h and k come from. So left 3 and then up 1. So for the function notation, we still do the same thing we've always done. I don't want to write it like this because this just doesn't make sense for function notation. I want to use my a, h, and k. So I have a negative 1/2 for my a. So negative 1/2 f of x. I have a negative 3, so I have to change the h, so I have to put plus 3 in there with it. And then I keep my k, which is plus 1 on the outside. This is actually how it should be written in function notation. So if we look back up here, I could have had my negative 1/2 cube root of x plus 3 and then plus 1 on the other side. And that's how you would do a cube root. So again, you can still just graph them and find the coordinates. Transformations still come from what is happening to it. The domain and range come from, again, the arrows. Make sure you know which direction your arrows are pointing in. Left and right means infinities. Up and down mean infinities. So whichever way the arrow is pointing, that's an infinity.